And we are live. Hello, everyone, and welcome to Curiosity's webinar, Why Every Organization Needs an AI Data Manager in 2026. For our regular listeners, you'll see that I'm hosting for today. That's just a temporary change. We've got our newest addition, Sophia, on the call, and she will be taking over going forward. So just a bit of housekeeping. Please message either myself or Sophia if you have any issues with audios or with screen sharing. You can message us through using the private chat function. You've all joined the webinar as attendees. That means you can listen and watch, but you can't speak live unless we give you specific permissions. We do want this session to be as interactive as possible, so please use the Q&A to ask us any questions, and one of the three of us will be able to get to you and answer your questions either live or during the Q&A section. And then also you can find interaction tabs. If we post any polls, they will be located here, there. Last thing to note is this session is being recorded, and you will receive the recording and the slides in an email tomorrow. Without further ado, let's get to the introductions. So, Hugh, would you like to introduce yourself first?
I thought you were going to introduce me.
Oh,
I'll do it the other way around. So, yeah, I've worked with Toby for ages and ages. Toby is kind of a specialist data engineer. He works on all sorts of kind of business intelligence projects, loads and loads of experience, very practical, and has worked, I guess, with, so we say 20 odd different customers, I guess, over the last 3 or 4 years, really trying to help them create better test data.
And Hugh Price, co-founder and chairman. So a lot of people refer to him as the godfather of test data.
God.
He has invented so many of the companies, and a lot of the solutions actually boil down to his inventions. He's been with Curiosity from the start, and he is absolutely integral to a lot of our vision and our innovation in this space.
Cool. Thank you, Toby. Okay, so you two can hear me fine, right?
Mm-hmm.
So there's no problems. Okay, so Toby, if you go to want to just mute out, I'll just going to kind of start you off, and then Toby, I'll bring you back in when we're ready to get your demos and your bits going. Okay, so at the moment you should be able to see slide agenda, grab bag of ideas and approaches. Am I correct? Sorry, Toby, just say yes or no.
Yep, we can see your screen here.
Great. Okay, so let's go. So what we're going to do today, it's a bit of a grab bag of ideas and approaches to kind of help people move sensibly towards pretty much revolutionizing TDM in a steady and easy way, and using AI to kind of help you get there. Now, I've been working with test data for about 40 years, and the reality is it's so much more fragmented and complicated nowadays. I would say very often we talk to customers and you say, what's your most important thing? And it could be one of 8 things. The second most important thing is the test data. And the problem with that means that it never really makes it to the top of the list. It's always a little bit of a forgotten child. Now, most people will have a sort of hodgepodge collection of tools. They won't really have coherent strategy. I may be wrong. You might have one or two of you who've got a brilliant coherent strategy, but for the most part, most companies don't really have a coherent strategy. It's very much associated with just get the job done, move on, and just carry on, keep on carrying on, I guess. So what we're going to do today is going to we're going to come up with some problem solutions and some strategies. The idea is, as part of the slide deck, there's some arguments to persuade management to sort of create a coherent and structured AI-driven approach to test data. So we're going to give you a bit of ammunition for that. Also, we're going to talk about the new problems that have arisen. If you look at Databricks, Toby and I were looking at it yesterday. Good product. We integrate with it. It's fine. But if you actually look at the devil in the detail inside those data lakes, there's a lot of things you have to worry about when you're putting data into those data lakes, in terms of kind of the understanding of the actual serious content within them. Integration. There are so many systems now trying to actually test the integration points, or I mean, end to end is almost impossible, but certainly the joining together of 2, 3, 4, 5 systems is quite a tricky process. The big one is now training and testing LLMs. I mean, that is, everyone's, betting all their economies on the fact that there's going to be this AI boom. But the reality is that the strategies for testing LLMs are pretty, I would say, rudimentary from what I've seen. And a lot of that is to do with the actual sort of understanding of the data. Obviously, moving stuff to the cloud, regulation, and this sort of comes back into data lakes, complex payloads. If you look at all the different documents that are flying around, the LLMs and data lakes are supposed to understand, those payloads are actually a really complicated animal that you need to deal with. So the other thing really is, which is basically AI can really help you with, is data understanding, really going to town on understanding your data, paying off all that lovely technical debt that everyone, of course, has managed to gather up over the years, creating a central data catalog, which Toby's going to talk a lot about, a data abstraction. By that I mean is basically an understanding from a business point of view, the business terminology mapping down to the bits and the bytes, of your vSAM message or your vSAM file or your Kafka message, and then the data lineage, really, which is how the data travels through your system. And really what we're going to talk about really is kind of how to use AI sensibly to drive efficiencies and quality. So that's kind of the plan today. Now, this is a little picture of the kind of components that we have in our framework. Now, the reality is that you will have a similar framework, but not quite so many buttons, I would imagine. You would also have maybe 4 or 5 different tools to do maybe masking. You might have a whole bunch of different tools to create synthetic data. You might have, some virtual some virtualization. Maybe you're using something like Delphix or something like that. Or you've got some virtual stubbing going on. So there's all sorts of things like that. And really, once you've with our structured things, everything is kind of callable, everything is fully API'd, and that means you can move towards using AI to actually kind of do agentic type processing, etc. So we're going to show you a little bit of that today, but for the most part, we're just going to kind of show you accelerators. Now, the modern data requirements, really, which is kind of where we should really be. The first one is a central data catalog, and Toby's going to talk about that. And that's really having something central within the organization. I mean, companies should have had it as soon as GDPR came out and people said, where, you write to a company and say, tell me where my, how much data you hold on me. To do that, you need a central data catalog. Most companies still do not have that, and it's a bit of a sort of firefight to try and pull that together. AI, LLM, and machine learning ready data. That's if you actually want to take advantage of AI, you actually do have to kind of understand the data and be able to present it to the LLM in a sort of coherent way. Otherwise, you're going to end up with it making some very dodgy assumptions. Data governance, all sorts of things going on where data needs to be held in certain locations. If you're moving stuff to the cloud, all those kind of different things. Do you actually really know where all your different data is, and do you keep it up to date? Orchestration capabilities, being able to push and pull data in and out of to provision environments, to provision data to the testers and developers all the way along a sprint cycle. AI-driven data documentation, auto-documenting your systems using AI. And then obviously the final thing is really compliant and secure data delivery from a central location or from your automation scripts or as part of your environment creation. Now, I'm going to just touch into one of my favorite subjects, which is black boxes. The reality is, I mean, we're just talking to some customers this morning, and actually, I think about 7 people on the call, probably 1 had a glimmering of what was actually going on in the application. The rest of them thought of the application really much as a black box with just some inputs and some outputs. So you have the data, which is a black box, and the people really kind of don't understand it. Then the requirements, what does your system do? You have a reasonable idea, but I wouldn't say that most people really know exactly everything that a system actually does. And now I've just included LLMs in as well, because obviously an LLM is actually a black box. You don't really understand what it's up to. You're just going to give it a question and it gives you an answer. So you don't know what you have. You can't specify exactly what you want. You're using technology, LLMs that is, that give you different answers every time. So that's kind of, I'm stating the problem here. That's really what we're after at this particular point. So evolving formats, bad data, changing rules, sensitive data appearing, sensitive data within the data, missing elements, as JSON structures change, some elements rename them, etc. Non-matching data, the data doesn't match, coming in from various different sources. The requirements, you think you know what you want. Can the data give it to you? Does everyone understand exactly what you want? And how ambiguous are the requirements? And I'm going to show you a little demo of using AI to kind of clean up your requirements. And then LLMs, a very good guessing machine, but you get a different answer for the same inputs. So how do you kind of manage that? Now, I'm just going to kind of leave this here, but in effect, if you're dealing with the systems, now I've been focusing a little bit on LLMs recently, but this actually applies to cloud systems or systems that you're not entirely familiar with. You do now need to think about much more rigorous approach to testing these black box systems. You need to be absolutely sure you understand the data in all its complexity. So that thing we talk about, which is the true understanding of the data that you are going to be processing. So the data at rest is moving through a process, and then at the end of that, the data is at rest again. Do you understand it? If you can understand where the state it's in, the state it's going to, and then also what the process is supposed to do, you've kind of solved IT, really. You also need to think about lots of broken data, putting out lots of invalid variations of data. And also this idea of coverage, which is kind of creating maybe 20,000 different types of data to make sure that you're increasing the decision gate testing. Most data is very, very similar. So you're actually just running the same test, 300 million times, whereas actually 20,000 would probably be better to cover most of it. You also need to make sure that you get the right result for the right reason, which is one of the big issues. Yeah, the claim was rejected. You've got a bug in there. All claims were rejected because a programmer left a switch on. All of those different types of things are really important. Okay. Now, test data and requirements acceleration. Now, let's just talk about where AI can really, practically help you. Now, we have now. I mean, I'm working with a lot of clients at the moment, and AI is it's just almost essential if you're a test data engineer, which is what I'm doing about half my time. It really can be a massive accelerator and very quickly bring benefits that were beyond the capabilities of most IT teams, and I would include myself in that. And I can write lots of clever utilities over the years. So it really does speed things up, and it actually now means that you can get a very cost-effective test data management team put together. We'll talk a little bit, if we have time at the end, about strategies about how to set that up. So the core places that you can have where it can really make a difference is technical debt, documentation and data characteristics. So really plowing through the data, pulling out all the enumerations, looking for data patterns, et cetera. Also looking at metadata, building out, pointing to the web to look at ISO transactions, also looking at your own internal documentation, etc., to fully document the system. And the other thing is to actually document the system continuously and to let people know when new columns and new tables and new APIs exist, fully documented with test cases, use cases, and example test data is now something you can do. Before, that would have been a whole project, and it would usually have been about 5 or 6 sprints behind. Requirements, much clearer, quicker, and more accurate. AI is really good at being able to help you build those requirements. There's lots of automation tools that have added a bit of AI to design the test cases. However, they don't work. The reality is that you do need the human and AI interaction. I would say it probably takes about 3 to 4 goes from picking up a requirement, I'll show you in a bit, to actually build a properly robust description of a requirement, aka something that's doing something to the system. AI can be a massive assistant and a time saver. I remember doing it with a Dutch insurance company. It took them 2 weeks and 5 people to create all the test cases. Lots of sticky pads. We came in, we had a product called Agile Designer at the time. We got that down to about a day. I would say with AI now, you can probably get that down to about maybe 2 to 3 hours now. So if you think about that, over the last sort of 15, 20 years, that's quite extraordinary. Common layers of data understanding can be created much faster with the help of AI. By this is what I'm saying is that people understanding the data by abstracting out the meaning of the data up into abstractions. And I'll talk about that a little bit later in terms of once you have abstracted data, it's much easier to be able to understand how good your data is and how effective your data is for testing and developing the system that you're working with. The other thing, obviously, AI can very quickly create secure data that matches with your test cases, greater coverage earlier, and as I said, saves masses of time. So actually, Toby, do you want to pick this up? I'm just going to mute out and over to you now for a little bit.
Yes, absolutely. So I think a big part of data management is actually creating our corporate dictionaries and actually gaining a great understanding of our data. Now, as soon as I got out of university and started working in the world of data, the biggest problem that I came across was an organization's ability to understand that data. That was true when I was working for a Big Four consulting firm in a data engineering role, and that's true when I'm working with test data as well. Now, the idea is that we can actually monitor and bring in all the stuff that's going on within your organization. Often it's very hard to have a centralized area where you can actually understand the growth of your data throughout your data landscape. You also need to know constantly where your changes and versionings are happening. Especially with AI being accelerated, I work with a lot of teams who are quite old-fashioned, and they're working in their DB2 mainframes, and their schema changes don't don't happen that much. I'm working with people working in the modern world within their cloud infrastructure, and schema changes, data type that's changing all the time. The change of growth and the rapid change of that has been absolutely astronomical. It's actually exciting. What that means is you've got to be able to validate the data. You've got to find when PII is being introduced into your landscape. And what we've developed with our AI data manager is to continuously monitor and actually help your data governance team identify new instances of PII, make sure that your data, any sensitive data, is being detailed in the correct way. We can then go one step further and actually start to produce the documentation which helps your team actually understand where that data is and how it's being remediated. Now, this can be throughout your whole data landscape. So especially when we've got a subject access request, we may need to have discovery throughout your whole data landscape, whether that's within some JSON files within your data lake, whether that's in a table within your warehouse on an on-premise SQL server. Maybe you've got some sensitive data in your lakehouse and Databricks. What we can do is we can go throughout your whole organization and bring it into one central place, and all of this can be interactive APIs, and all of this amazing data that we gather within your different environments, dev, QA, pre-prod, it can all be interacted with API, and it can also be ingested by whichever LLM you have within your organization. Now, if we move on to what this means for your commercial scanning. So, for instance, it's always very, very important to have your data catalog as up to date as possible. And with your AI data manager, you can keep that corporate dictionary up to date within real time. We can look at the actual data, and we can actually do analysis between that. So, for instance, quite often you will have data sources which the column names are useful, but they won't give you an exact match. We actually need to go and find that ID throughout your data landscape and create that match. And if we can flag one instance of sensitive data, we know how that spreads throughout your data landscape, and we can bring that in. We also need to make sure that we are categorizing it from a business perspective. So if we need to know that that is a first name, it's a last name, it's got some sensitive information about your gender, your date of birth, we can also categorize that, and therefore it will be really useful for our data management governance teams to be able to make sure that data is being remediated in the correct way. Now, the Curiosity software, we bring a wealth of experience in using AI and also other advanced techniques to actually scan all your data sources and bring that within that centralized corporate dictionary. And if we move on here. So really, and this approach has worked for the vast majority of engagements I've been on. The first thing we do is when we land within an organization or we're helping an organization is we want to start sending off our crawlers to actually get all that great information within an organization's data landscape. And then we start to find the relationships. So often we've got organizations which are where the data is fabricated all over the place. So they're installing their data fabric, they're installing their data mesh architecture, but the data is still all over the place. And we start to bring that centralized view, and it can really start to help bring in those relationships. We then start to look at the quality. Now, when everyone's going as fast as possible, they're developing their code, they're building up their applications. Those relationships aren't imposed at the database level, and they're definitely not imposed between different microservices. What we can come in and do is we can actually look at that data quality, look at the relationships between your different technologies, and actually ensure the data is correct. And we can actually, when we've got a vast number of data quality routines, which we can have a look at it. And then once we've got that web, we understand how the data flows throughout an organization. That's when we start to easily look for personal data, not just within one data source, but throughout your whole data landscape, which is where the biggest issues, and that's where the most work normally happens, especially with this cross-system relationships. Now, Hugh, do you want me to do if I'm just finishing this slide, so you can then use AI to document all of this. Now, it used to be that you'd have teams and teams within your data governance section who would be helping you with your documentation and actually documenting these data structures. That's a thing of the past now. This process is much more automated. This will be in most cataloging tools, but we can really go one step further and start producing that external documentation and integrate with other tools as well. We're using some of the most advanced deep learning techniques to actually really understand those relationships and also understand their probabilities. And then we can also go and create your training data sets, and we can go and create bits of data that we need to go and test your different bits of the organization. And then finally, we can go and then actually build that into your tests. So for instance, instead of having these big chunks of data all over the place, and as we're getting more and more data within our organization, storage costs are getting higher and higher. So the ability to actually have small, succinct bits of data which do the job, rather than have full data sets, is becoming increasingly more valuable to our users. And therefore, we can allocate that specific, succinct bit of data to the specific use case. And this all builds into our centralized data cataloging, which I'm just about to show you next. So go on to see if I just go and share my screen. So here we are within the tool, and I've got my Curiosity AI assistant here. Now, when we're talking about our AI data manager, we're really talking about the AI capabilities within our corporate data dictionary that I'm showing you right here. So here I can ask it to go and do some scanning. I can also ask it to go and do some table groups. So table groups are really understand how our bits of data within our ecosystem come together. So if I'm a BI team, I might want to know what tables and data are part of the sales orders. I might also want to know which one of my tables are actually for reporting or aggregate tables, especially if I'm looking to build dashboards or point LLM to where my important information is. We can also have a look at any foreign keys within the data source. These can also be soft relationships, i.e. relationships that we have discovered ourselves. And these can be added automatically through our AI scanning capabilities, or we can actually add them manually if we would like to. And then all this information here in terms of the table groups, the row counts, your data quality scores, and all these descriptions here, these have all been initially done by our AI data manager, and it comes in and helps you get a really good understanding of what your tables are. This also goes down to the column level. So here we can see what our columns are. It's identified some potential PII data in terms of somebody's international bank account. So that has been flagged, and therefore our data governance team can come in and actually deal with these in the appropriate way to make sure we are meeting our regulations. As we can see, our customers table, unsurprisingly, that's got some PII in it as well. So all of this information is being constantly monitored and made sure it's being correct by our AI data manager. Now, what's really interesting, actually, this is actually in a DB2 instance. So not only can we do this with the most modern technology, like in your data platforms, we can also do it in the old stuff, which is looking around, which is typically a lot harder to work with more modern techniques. And actually, especially when you've got the people who have created these instances are now retired, and all that information that is just not in the business at the moment, we can come in and we can actually start to really untangle a lot of that technical debt. Then if I go back to our data dictionary and look at our databases, and we can go at the connection level, what's really important here is we can actually set up a lot of these data insight jobs. So these are almost like little tasks that we can ask our data manager to go and keep on top of for a data source. So for instance, I might want it to keep update with any PII data which has been added. I think the biggest problems that Hugh highlighted earlier in the call, with these insight jobs, we can ask our AI assistant to go and have a look at that and keep up to date with PII data. And this can be done every single time a schema change is done. So I can just change the execution type here. If I look into here, after scan, on schedule, our first scan. So yeah, after scan, that would mean every time that a change is being detected, this task would be executed. Here, and there's so many different ways we can do. We can have our data validation being continuously scanning. This is part of the data quality techniques that I was talking to you about beforehand, where we're looking at relationships both in this source and throughout our data landscape to make sure it is good. And we can also use this very much like most LLM integration, like Windows, you can use. So we can ask it a lot of things. So for instance, can you give me the tables for a sales order? If I just then go and ask it that, it will go and give me a bunch of tables which it thinks will be relevant for this connection. Now I can go back to this at load 10. Here we go. It's actually a bit quicker than I expected to. It's now giving me the tables for that sales order. So this gives me a great way to interact with our corporate data dictionary and also keep on top of a lot of our data management and data governance tasks. It can also do data lineage. It can help you with your data flows throughout your organization. So I think that's all I wanted to demo for our AI data manager. Hugh, is there anything that you think would be good for me to show?
No, I think that's fine. I mean, once you've got these kind of agents running, what you can think about there is like that data validation thing. So what we're doing there is to make sure that you haven't once you've scanned the data, built all the business relationships, you want to make sure you're not introducing errors into it. So development's going on, QA is going on, you're just about to do a release, you've run a bunch of automated tests. We would have that validation running all the time, and if you find some kind of data error according to the business model that has been discovered that you've worked on together, then bingo, that's going to come up and it's going to notify the teams directly from the AI engines to say, you've actually introduced some data errors here, and you find that actually before you put it into production. What a concept, eh? Okay, thanks, Toby. Let me just share my screen. And go back to me. And with luck, you should see data requirements. PowerPoint. Yep. You okay? Toby confirm that? Yep. Okay. Perfect. Okay. I'm going to talk a little bit about requirements now. At the moment, now you've got some data, you've got some requirements. Out of those requirements, you should have an expected result, and also, and this is kind of one of the things that I kind of talk about a lot. So is really the expected reason you got that result. And this is a thing called observability, that you got the right result for the right reason. The number of times, I think there's 50 odd people on this call, the number of times someone's fixed a bug and pretty much the whole system's broken because that bug has been masking a load of other things behind it as well. And obviously the data gets converted to code, and then you get an actual result, you get an actual reason, and then the idea is you're comparing them really. So that's kind of it in a nutshell. Sorry, just carry on here. So you know what you have, you know what you want, you know how it did it, you can check that it worked. The problems: this requires a systematic approach, a clear, unambiguous requirement, a full understanding of the data, and a testable system. This slide is kind of the description of what IT should be, really, isn't it, if you think about it? Now, with LLM development, we're really much more into the world of black box. So this is I'm actually doing a presentation at Eurostar. I'll give you the details, where I'm talking about how to test LLM systems. So if you are coming, it'd be great to let me know. Be glad. Good to see you over there. So now the advantage with, obviously you've got a problem with LLM in that it is very much a black box, and you get different reasons. You get unpredictable results. Let's call that. Let's be charitable and use it that. So you've got data, you've got a requirement, you've got expected result and expected reason. Now, the advantage of having a known data dictionary is massive. And a known data dictionary means that all that work that Toby was showing you is actually something that the LLM can sit on top of. Now, what he didn't show you was that we've actually done some fairly deep scanning underneath that. So if you go down to the column level, we would have all the equivalence classes, we would have all of the kind of minimums, maxes, ranges, and things within that. That then gives you a lot of dictionary information, which can actually feed that into your LLMs. You've got a refined language glossary, prompts. Now, again, prompts are requirements, and you should really think about modeling out those prompts. You've got expected result, expected reason. You've got created data. You've got actual results and an actual reason. Now, one of the things that it's quite good to do with when you're dealing with LLMs is to get the LLM to tell you the methodology it used when it ever gives you a result, because if that changes and it doesn't match with your expected reason, then you have an issue. Something's changed. It might come, the result might be the same, but the actual reason that it came up with it has changed. That's kind of really important to think about. So let's just, in a nutshell, the data requirements are intimately connected, and that's true for pretty much every part of development. Now I'm just going to quickly show you some kind of using AI to help you with this requirement process. So let me just hop off this for a second. How do I get out of this? I can't get out of. Sure, I'll come back to that later. Right, so if we go over here now, this basically is some text, and this is just an early stage set of requirements. The promotion requires customers to run a minimum 10 miles per week in order to qualify for a free drink, etc., etc. Now we have a ton of importers. Now this could, you could bring it in from Gherkin, you could bring it from some existing test cases, some code we can actually reverse engineer it. We've got some, quite a lot of stuff is in Excel. There's all sorts of BPMN things. There's all sorts of connectors, Swagger specs, etc., etc. But if you look at this requirement, what we do then is we just run our AI engine, and what it will do is it will create you a model. And what it's really done is it's come in and actually built all the kind of decision gates here for you, which is kind of showing you through validate, proof, authenticity, and etc., etc., etc. And in effect, what it's doing, it's created you a nice sort of BPMN diagram in terms of how your requirement should work. Now, this kind of comes back to the point of it takes you 3 or 4 goes to get this right, because you're trying to create a common understanding between the user in terms of what they want, the systems analyst, whoever that person is, the programmer, and the tester as well. And if you're a tester, you should really be kind of a critical analyst. And what you'll do is you'll find, well, that's not right. That should come after that. That doesn't occur if that. And you'll spend a fair bit of time actually kind of reorganizing it. And that's what AI has changed. Actually, the difference between the AI engines has improved dramatically in terms of how much better this has got release to release. But it still can't interpret things that you've missed, and also things that has been misunderstood between the 4 types of users. Now, this is one that we've kind of manually adjusted based on a better understanding. And what we'll also do at this stage is we would automatically build you sets of test cases. Each one of those is in effect a different path, a set of paths to do that. And what we can also do out of that is we can also then build you a set of test data. And these, think about this, each one of those is a different set of values that have been that you could then use to drive in, and then from that we would then use these then to create the data that we need, or go find the data that matches with these test cases. Now, the other thing that you have as well is that we've also then got lots and lots of these. Once you've got your model, you've then got lots of different things you can do to it. So if you look at the different prompts, you could come in and say, well, okay, just review it for me, give me a summary. I want to go and maybe I want to build some equivalence classes. There's tons and tons of things sitting behind. We've built lots and lots of kind of internal prompts which sit on top of our dictionary, and a lot of these prompts are you can obviously use them yourself. User story creation. If you look at this one, user story creation, what I've asked it to do is to create me a set of user stories so I can go back to my user and verify that that is correct. Now, if we go and look at, so that's a kind of basic requirements. Then if you think about test data itself, here what we're actually doing is we're actually building out a set of requirements to do with different sets of data that we're going to need. And that's really thinking about coverage. We've got actually, in this case, 57 different combinations of data, and that is also been modeled again by AI. So we picked up all the data elements, all the equivalence classes, and actually created you that model from that. So AI is just absolutely brilliant at this. Like I said, we went from 2 weeks to about a day using just some clever maths, but actually once you stick some AI, some clever maths in there as well, you can actually bring it down to 2 to 3 hours to build a pretty robust set of requirements. So let me just carry on a little bit. So just to clarify what I was talking about, so you've got basically the user analyst, the programmer, the tester, and what you're trying to do is to help get AI to help you as quickly as possible get those 4 circles to sit on top of each other so you have a common understanding. Once you've done that, you also get your use cases and your test cases out of that as well, and also the matching test data. So just moving on a little bit. Now, where else can you use AI? So one of the things that is really useful is this idea. So complex payloads. Our next talk is all about complex payloads, which is pretty much the lifeblood of anything that feeds any of your data lakes, business intelligence, or AI systems. And they're actually they're tricky. They're tricky to create, and they're tricky to create on demand for the tests, to validate the tests you're interested in. Now, one of the techniques we use is that we can pretty much parse anything, and we actually push that inside a database, which then allows you to create a deeper understanding of what's going on inside the message streams of data. Could be a set of Kafka messages, could be a whole bunch of PDFs coming in from customers that you need to parse out and to make some deeper understanding from it. But actually, what you're also interested in is this business abstraction. And the business abstraction is looking at business terminology mapped down to the bits and bytes. And AI is really good at that. If you give it that strong dictionary and some of the business terminology, and you've gone through the dictionary creation correctly, then you can very easily create these abstracted layers. These abstracted layers are really useful. It allows you to then go off and do things like finding data more accurately. So find me quite complex requests, which previously you would have to kind of do by hand and look things up, or you'd have to be really good at SQL to try and actually track that data down. And also you'd have to actually understand your data. So that's really something where AI can help a lot. And also, I'm just going to show you a little demo in a minute, which basically allows you to just type in text into the tool to go and find the data that I'm interested in. So let's just carry on a little bit. Let me just click on play on this one. Hopefully that will run. So basically what we have here is we are looking for some data in our development system. Now we're actually typing in basically in English. I want to grade us a reasonable credit score, but I also want to make sure that they've got an increasing credit score and they've actually got some money in their account. I'm also going to capture this as a test case. So I need to go and find some data for my particular test case that I'm working on. I need 2 of them. What we've done is we've taken that AI, that text, we've converted that to SQL. We've gone hunted for the data across multiple tables, and then we've then trapped that data. It's your data, in effect, using our allocation system for 10 days. There's the keys, and that's the SQL that has been actually constructed from basically the English itself. So if you think about that, that just means that any tester or developer can actually cast their queries in a reasonably strong English or textual format. Now, it does get it wrong from time to time, and then you have to be a little bit more accurate, but it doesn't take long to, and we can also add in additional prompts as well excuse me, let me just end show and move on to this one. So that's that one. So that's that's a really useful way to think about it. This abstracting of the data out, this ability to pass that in as text, and then push those queries then out into quite complicated databases, or as we said in our case, we pull the messages into databases, and from that we can then we can then go out and find the data that you want. If the data is obviously not there, then we can start thinking about actually making the missing data. So now once you've kind of got this business abstraction, then you can get into things like trend analysis, um, which is quite useful because you now actually have some information which is useful for AI to go and feed on to see, well, what's actually happening with the systems. Maybe you're interested in different trends, in terms of your production and development systems, your attribute coverage, where are the gaps in the data that's missing between the two. AI is really good at this because you can basically just give it the two sets of characteristics and it can tell you what's missing from one to the other. Machine learning, now that's machine learning is a whole world in itself, but this ability to actually do some really deep mining of the data, and that actually brings some great benefits, which I'll talk about a little bit in a bit. Data validation, obviously, we talked about that, and then also this ability to create bad data. So create me lots of bad data, or enough bad data to, if you're testing LLMs, to try and mess with the LLM's head. Quite often when I've got a stable LLM, I will start throwing bad data at it to see if it can actually, if it doesn't just mess up. So actually pushing bad data into systems is actually a really good way to make sure that your systems are pretty robust and can handle it. The other thing then is now we're moving to the world of actually generating data. You have, obviously, if you've got a clear requirement, which we just kind of showed you how to do that, which is mostly AI driven, that helps you build this model of what the data should look like, which allows us to create all these variations of data. You can also actually use some kind of AI created variations of data. It's not as good as the combination of humans and AI. This is a much more robust method, and also you tend to end up with more data, and you also don't know what the expected results are here. Coming back to machine learning, the advantage of using machine learning is that you can generate similar data, either more of it. So you might say have created an initial set of data, a couple 100,000 rows in my development environment, and I want to create 20 million rows to simulate the product next year, but I need it to have the same characteristics as data, so you can use machine learning to do that generation. Or the other one is a reverse. You've trained it on 20 million rows, and you actually only need maybe 5,000 rows to test all your prompts work correctly. So for that, you can actually use machine learning to actually push data to step it up or to step it down, depending on the use case that you are interested in. Okay. So this is just a little bit more about some of the machine learning type algorithms. Now, machine learning, AI actually uses machine learning, so people get slightly confused in terms of what machine learning is. But AI also has its kind of, it has its own interpretations of what machine learning is doing as well. So from our point of view, it's kind of the same. We do have some very strong machine learning algorithms, which, for the most part, the tuning of them is really the important part. AI will generally get that bit wrong. Now, what you're really trying to do is to understand the characteristics of the data, so that when you generate the data, enough data to make sure that you are actually getting that same characteristics of data, so you're getting that same spread of data that looks something like that. So this has the advantage, massive advantage, by the way, is that you can maybe create 10% of the data, and it is not production data. The amount of companies that are still using production data, which is, shall we say, poorly masked, which still contains very, very easily accessible sensitive data, is quite extraordinary. But this method of using AI machine learning to actually generate the data with the same characteristics is actually a massive step forward in terms of how companies really should start thinking about data and how they should be populating data into the lower environments. And let's move on. So let me just run through kind of a few recommendations, and then I'll go into some kind of strategies. So deep analysis of all the different groups of data that you have. If you've got payloads, which is basically now much more of your systems are now actually analyzing the raw data, okay, the raw messages if you're trying to make business decisions. Now you need to be able to understand what data is in those payloads if you can validate that you're going to get the expected results that you wanted out of them. Okay, validating the content as well. How much bad data have we got in there? Again, AI is really good at this. It'll help you build those rules, and then we can construct the queries to make sure that to actually analyze the data to see how much good and bad data you've got. Central dictionary of structures and versions. I cannot stress how easy this is now. This could take maybe, I think we worked for one customer, it took us maybe 18 months to build up a reasonably good dictionary. As we came across each system, within probably 3 to 4 days now, you could probably get 50 to 60% of your core systems and applications documented. And as Toby said, scanning it for PII, notifying people when stuff comes in, and most of that is driven by that AI acceleration. Auto notification of changes across the teams. So that's really, things are changing all the time, and the thing you need to do is you never work in isolation as a team. You have all other people depending upon you. You're either ahead of them, behind them, they're waiting for you, they're a sister system, they're using your APIs, but what they need to know is, what are you up to? You're about to change this API structure. They would get notified and you say, oh, great. And they can plan that in their workflow. They don't have to wait for you to get around to sending them something, which then sort of, they're auto notified that something's changes. Creating a central portal, that's critical to find and request data and payloads. I think that's probably the most useful thing as well, is to actually bring it all under the hood into one place. So you end up with these really nice so it also allows you to track what people are up to. It also so when you go from release to release, you can say, right, what have they been requesting a lot of in the last release? Okay, maybe we should pre-populate our environment with a lot of those. They've done a lot of data generation requests for a specific thing. If it's all going through a central portal, you can track everything. And then you can say, well, next time we do it, we're learning from that. If we're setting up another environment, we need to make sure that all those requests are going to be satisfied. Creating models of expected behavior, build the input and expected results. Coherent, structured AI-driven development strategy. You're no doubt using AI to help your programmers and to actually kind of create code. That's so we're basically back to the 80s in terms of how quickly we can develop. So after slowing down for the last 30 years, just a bit of an aside there. So now, if you think about that also you can then use AI if you've got a corporate data dictionary to request or make the data, assuming you've got those you can then just connect into the APIs to be able to do that. And then the other one, just a quick reminder, is don't forget bad data and integrated data. So just in terms of strategies, now the thing about it, no doubt in all the organizations, there are initiatives going on, and they're migrating from legacy, moving to the cloud, business intelligence to make corporate decisions, cutting costs. You've had a data breach, and now you've got massive data regulation sitting on top of things. All of those are kind of initiatives. Those basically then come down into smaller projects, which is basically, how to test LLMs, a structured control of data and prompts. So there's all sorts of different things that are going on as small projects. I need to create a bunch of smaller subsetted database. I need to clone data from production into development, so to test bugs. Now, all of these are things that teams are doing all the time. These are initiatives, but the reality is what you really should be doing is you should be thinking about building this kind of more strategic initiatives and trying to persuade your management that actually having a core set of practices or a guild or a small team what actually can use AI consistently for the provisioning of initially point data, but then out into the provisioning of environments, provisioning of data into automation frameworks, the provisioning of data into the catalog to make sure that people are understanding what's going on. All of these types of things are really good strategic initiatives, and the reality is with AI that is so much quicker. I cannot stress how much easier that is now to be able to do that. Okay, now let's just roll on a little bit. So you can read these, but basically there's, the example improvements. I mean, as a rule of thumb over the years, I would say that in 6 sprints, if you've got a good test data strategy, you should be able to get it done in 5 sprints, because you'll find, and the reason for that is you'll find a lot of bugs way earlier, and you won't find them in pre-prod, and actually the number of bugs that make it through to production goes down dramatically. The other big thing is that people don't spend less time waiting for data. A lot of people can't test because they're either having to set the data up manually or they're waiting for some other data. So this is a bit of an advert for us. Again, you can read that at your leisure. Central data catalog, AI acceleration, it's fundamental to everything that we do, designing and modeling requirements and data. And how can we help? I think that's pretty much everything we've covered. So questions. I am going to stop talking for a bit. Toby and Sophia, do you want to?
Yeah, we can take the questions and discussions one.
While I have a quick drink.
Yeah, thank you very much for that, Hugh. So Sophia, I'm just looking at the Q&A section. Any questions which stand out to you that have come in?
We pretty much answer most of them in chat, really.
So yeah, one private one that got sent to me is that would there be one project recently that you wish had an AI data manager and why? So I'll take that one first. So I've got one of my favorite clients who I work with a lot of the time. They really struggle to actually gain an understanding of the data, especially when it becomes with these SAP systems that they're working with and all these custom tables and what fields are in. And I really wish that they had an AI data manager in there because it really helps us with our relationships, the relationships within the data, finding out the data types and the indexes. And they're looking to mask huge amounts of data at the moment, and it would really help us understand that and what data actually needs to be masked and why. So that's one that came to the top of my head. Hugh, have you got any on yours?
Actually, that's a good point. Actually, there was one thing that you need to be a little bit careful about with AI, obviously, is, we've got these great big avaricious American companies who are harvesting your data, and that's really, how they're going to make the money back on this. Now, I've actually switched to using some kind of open source systems recently for AI and LLMs. And if you think about the stuff that corporations are dealing with, it's actually better to probably have something which is around about 80% the functionality of this kind of super bleeding edge stuff, because you have much more control over it, and also you control which data is going in and out. There is absolutely no way or no reason that your metadata should be of interest, should be something. In effect, it would end up in the public cloud if you're scanning that using one of the sort of open source things, one of the more commercial, ChatGPTs or whatever. And then someone says, oh, can you create me a schema to create the most advanced healthcare booking system in the world? And strangely, they've already harvested yours. So all of this information should really be, it's kind of super secret, it's your secret source. So I think the market is actually going to probably switch to people having their own in-house LLMs, or LLMs that don't, which don't retain. So I'm actually switched to using personally use a Swiss one, which is also eco because it uses it heats houses with its excess energy. So so I think there's going to be a switch around to that. And when I talk about AI LLM testing in the summer, I will actually talk about that, because it also allows you to whenever you're testing lots of moving parts, you need to be able to freeze certain parts. And if you're using these commercial ones, they're constantly moving. So is it that's moved, or is it you that's moved? Have one of your APIs changed or something like that? So I think that's something else that should really be considered in terms of kind of thinking about these sort of issues. Toby, any thoughts on that one?
No, I think it's a good one. I'm constantly trying to work out which LLMs I should be using. Unfortunately, I'm a bit of a sheep, and I keep using ChatGPT, and I really feel like I should be trying to use some of the other ones like Grok or Claude, for instance.
Yeah, I'll show you some ones I've got. So let me just quickly. We've just got to do some wrap-up slides here actually as well. So let me just go through to these. So just to talk about next week. The next one is complex payloads. Now we're really going into the weeds. And this, if you have actually Toby is doing some of this work as well. It's like lots of kind of PDF documents. You've got really complicated ISO messages, all of these sort of financial instruments that are flying around. You know, all of the payment routes are now changing, so they're not all going to the US anymore. Some are, you know, the BRICS are bringing up. So there's a lot of stuff going on with those payments, with those kind of really complicated payloads. And you need to be able to create them quickly, understand them, test them much more accurately. So that's really what we're talking about. And then it really is a lot in the weeds if you're into that space. And if you think about it, like a lot of the LLMs are actually trained on these babies as well. I would also say, if any of you guys are going to Eurostar, love to know if you're going. Also, I can get you a discount, so just ping me a message and I'll send you the discount code and I'll get you 10% off, I do believe. So I think that's it. Sophia, any final thoughts?
No, not really.
Good. All right, next time you're running it.
All right.
Okay. Thanks, everyone. Really appreciate it. We will, Sophia will follow up with the recording, plus any other bits and bobs we can think of. And we'll also send you the slides. Hopefully they'll be useful to you if you need to persuade some managers, etc., to actually get involved with some of this stuff. Great. Thank you all so much.
Thank you very much, guys. Have a great day. Bye.